Our project with Winnebago focuses specifically on their wire harness assembly process. Shown here is an example of one of the hundreds of different models of harnesses that they assemble. The harness is composed of different sized housings, shown here, TR or temperature resistant endings, pictured next, and lastly, BS or butt splice endings. It's very easy for an operator to make an error in this process as they can easily switch a wire around, and a common error is operators will misorder the wires within the housing, and this leads to a faulty harness. To resolve this conflict, we purchased input-output boxes, shown here. How these work in regards to a harness is that you assign each one of these slots to a specific wire input or the start of the wire, and you assign a different slot to the end or the output of that wire. The box sends out a 5-volt signal through the inputs, and if it receives that same 5-volt signal in the output, you know that the harness is wired correctly. So this is a general idea of how you use this box to test if a harness is okay. Shown here is the hexadecimal code that the box reads. Each line represents a different wire name within the harness. How each line reads is it tells the box which slots it should send 5 volts out and which slots it should be listening for the 5 volts in. Shown here is our fully functioning solution. The box wired so it can test all 3 harnesses that Winnebago wanted us to test. You can see that each housing has colored tags on it. Each of these TR boxes has labels, and each of the BS connections has labels as well. And these are all to make it as easy as possible for the operator to make the necessary connections so that they can quickly test each harness. Shown here is an example of the necessary steps that the operator must go through to test a harness. They must plug in the housings, make bare wire connections, and lastly, plug in the BR and TS. Again, you can see how all these labels are extremely helpful, so the operator knows exactly what goes where. Once all connections are finalized, the operator must then utilize the user interface to receive feedback on if the harness is pass or fail. So here you can see all the features of it. First, you must select the test code file that I showed you earlier based on the corresponding harness. And as you can see, the result is a fail. Shown here are the locations of where the errors can possibly be. Now that the operator knows exactly where the errors are, they can go out, find those wires very easily with the labels, and switch them. Lots of the times it's as easy as misplacing 2 wires like shown below. Now they can go back to their testing computer and rerun the test. Now that we think the errors are solved, we can go back to the user interface, click rerun test, and voila, we see that the harness now passes. They see a little note, all wires are connected correctly, so this harness is A-OK. The last tool we provided Winnebago was an Excel template that provides them the ability to automatically generate the test codes. We had to manually create them, and it is a very long, tedious process. Here you can see all of the inputs and outputs that must be recorded, all of the wire families, and then you hit the macro enable button, create text file, and it has been created and stored. And you can go look, and here is the text file that would take us normally at least an hour to create. So this is very handy for Winnebago to make test codes for future harnesses so they can expand this testing process.